So basically, everything we covered so far was about the relational database. So basically, based on what we covered so far, now we are able to implement the database system. So if we have a business event and business rules, we are able to infer the conceptual ER diagram. That's basically the stage of conceptual data modeling. And once we have a conceptual diagram, we can translate that into a relational model. So that's basically exactly making the blueprint for the database implementation. So once we have a relational model, the next step is very straightforward. So we simply use that to create physical implementation in the database system. And then we can utilize SQL to add data or edit data or retrieve data stored in the SQL server. So that's all we covered, and basically based on what we covered so far, if you utilize those knowledge, you are able to manage and utilize the database server for every purpose, for your organization and for other purpose. So this is another ERD exercise based on the Pine Valley Furniture Company. So we already looked at the company's background, which is uploaded at the Blackboard. And according to that, there are 5 major business events that's happening in this company. So one is manufacturing, which is about making a furniture. And the second is sales, which is selling order to the customer. The third is order handling. And then we have employee management. So the company also has some employees. And also we have to manage their raw materials. Basically, they need these materials to build the furniture in this company. So I'm going to briefly show how we can actually make and do conceptual data modeling based on each of these business events so that you can get more familiarized with this step. The first business event was this, the manufacturing. The first thing is this. So actually here, I already inferred the business rules based on each business event, but in the future, in your company, if you have a certain business event, actually inferring business rule like this will be completely your job if you have to design the database system. So in this case, just for to reduce the time amount we have to spend, so I already inferred it for you here, so we can actually do conceptual data modeling based on these business rules. So if you look at here, basically for the manufacturing, there are several rules. The first rule is this: the product is made of a number of raw materials, and at least one material should be used to make a product. However, also any number of raw materials may be used to make a product. So basically, to create a product, we need raw materials, and each raw materials should be used to make at least one product and can be used for many other products. And there are multiple manufacturing facilities here in this company, and each facility makes at least one product, but it can potentially make many products. And a product can be also made in any of the facility the company has. So based on this, if we are trying to design the database system to keep the information related to the manufacturing process in this company, we have to design 3 entities first. The first one is a product. We want to store information about the product this company is making. So we can have a product entity with the unique ID for the product, which is a product ID. And then we can have some attributes like a name and other stuff. And also the raw materials. So the company has to keep the record of how many raw materials they have so that they exactly know how the product is made of these materials. So in this case, I can create the material ID for the primary key and the material name as an attribute like this. So there's a relationship between product and raw materials because product is made of raw materials. And for the cardinality, we can, once we have documented the rules, we can just follow that. So it says that at least one material should be used to make a product. So from the product's perspective, there should be at least one material we use to make a product. and any number of raw material can be used to make a product. So for each product, it can consist of one material or many materials. And if the company has raw material in the system, this material should be used to make a product. So for that, it says that each raw material should be used to make at least one product. So from the raw materials perspective, it can be used to make at least one product, and it can be also used to make many other products. And another information, additional information we can store here is this. So basically, when we design the furniture, something like a chair, then we may need some wood, maybe 3 packs of wood or something like that, or we may need some nails or something like that. So just for example, so there we may want to keep this quantity information too. So how many wood will be used to make one chair and how many nails will be used to make one chair, something like that. So if we want to keep those kind of record in the database system, in this case, we can store this information in this made of relationship basically, because this made of relationship is a many-to-many relationship that keeps information about the assignment. So for each product, for each raw material, we can keep how many quantity of that material will be used to make the product. So that will be there. And another information here we want to store is the facility. So we can create a facility entity with the facility ID as primary key and some other additional information like location of the facility. So basically this product is made in the facility. So company has a multiple facility and some facility will be used to make a certain product. Another facility will be used to make another product. So the company wants to record that information in the database system. Then basically there should be a relationship between these two. So product will be made in a certain facility. And for the cardinality, we can check the relation, the rules, business rules. It says that each facility make at least one product. So at least one product, potentially many products can be made in each facility. And from the product perspective, a product can be made in any of these facilities. So if the company has a product, it should be made in at least one facility, and potentially it can be made in many different facilities like this. So for this manufacturing business event, we should be able to infer ER diagram like this. So that will be an example for the manufacturing business event. Okay, let's look at the next one. So next one is sales. So the business rule I inferred is this basically for the sales business event. Each customer belongs to only one sales region. So basically we want to keep the information about our customer in the database system. So we want to record the customer information. And also based on the sales region, we may manage them differently. So for some sales region, we may give a different like a coupon or marketing service, something like that. So there's customer and sales region. We want to keep information. And customer can place any number of order to buy a furniture product. So customer can place the order to buy a furniture product. And each order can contain multiple products. Basically order and the product. So there are several information we want to keep record in our database system. So first of all, the customer is the most important information here. So we can create the customer entity. For customer entity, we can have a customer ID as primary key, and we can also keep record of other customer information, something like a name, their address, or email, phone number, something like that, just for example. And let's look at the first rule. So customer belongs to only one sales region. So we also want to have information about the region and keep that information in our database system. So for this, we can have the region ID as a primary key and the region name as attribute, something like that. So customer belongs to or lives in a certain region, basically. So customer belongs to only one sales region. So if there's customer, they can belong to only one sales area, and each sales area can have multiple customer. Here it can be 0 or 1. It doesn't make sense. It doesn't matter. I just put 1 as minimum cardinality in this case. So that's basically the first business rule about information and relationship between customer and the region. And the second is customer makes an order about the product. So the reason we have information about customer is because we want to manage their order about what they are buying and what kind of products they want to purchase. So here, let's go through the second business rule here. So customer can place any number of orders. So we can keep the order as a separate entity here, and we can have this place relationship. Customer place an order, and for the order entity, we can have order ID as primary key, and maybe order date as additional attribute. So customer can place any number of orders. So customer, let's just say the customer signed up for this company to get some information about their products, but did not make any order. The minimum cardinality will be 0 in this case because he didn't place any order. And potentially he can make any number of order. So the maximum cardinality in this case will be many. And for each order customer made, how many customer can make an order, which will be 1 and 1. So if a customer made an order and order is there, and this order should be made by one and only one customer. So it belongs to one customer. So yeah, we can create this relationship and the cardinality. And each order will contain product. So we can create the product entity here, and we can create the product ID as a primary key. And for this product entity, actually, we already made that here. So we had some attributes added into this entity. So I'm going to skip putting additional attribute here in this case, and I simply go to the making relationship between order and product. So order will contain product. And based on the rule, each order can contain multiple products. So if a customer makes an order, in that order there should be at least one product. That's straightforward. And potentially, customer can include many different products in one order. So the cardinality will be 1 and many. And for each product, it can be included in many order. So if the product is really popular, many people will place it. So the maximum cardinality will be many. However, the product is never placed in or included in any order. The minimum cardinality will be 0 in this case. So we can create this many-to-many relationship between order and product. And also it's possible that when customer makes an order about a product, he may order the same product multiple times. So not just one product, he may like the product and he may order 3 products. So if we want to keep that quantity information, we can keep it here in this many-to-many relationship. Because this contain many-to-many relationship will keep the information of assignment about each order and each product. So which product is included in each order, and when that assignment is made, how many quantity was ordered. So we can keep that additional attribute inside this many-to-many relationship in this case. So based on this business event and the rules, this ER diagram will be basically the final ERD for this specific sales business event. Let's go to the next one. So order handling. So this one, so it's about how salesperson handles order. So when the company receives the order, this order should be handled by the salesperson to be processed. So each salesperson in this company also belongs to a specific sales region. So salesperson in a certain sales region will manage customer in the same area basically. So we can create that first. Let's just start from there. So there's a salesperson, and we can have the employee ID, and we can have other information like office or email or something like that. And earlier we created this region entity with the region ID as primary key for the customer information. And for the salesperson, we can use this same entity. So salesperson belongs to a certain sales area. And based on the business rule, in each sales region, there exists multiple salesperson. So in each region, there could be multiple salesperson. And if the company has a sales area, there should be at least one salesperson working in that area. And each salesperson should belong to only one sales area in this case. Only one. Okay, so that was the first rule. And the second rule is this: each order is handled by a single dedicated salesperson. So we have the order, which is from earlier ER diagram, which is made by a customer. So at that time, we use the order ID as a primary key. So it's the same entity. And each order will be handled by a salesperson. And it says that each order is handled by a single dedicated salesperson. So if there is an order, if there exists an order, there should be at least one and at most one salesperson who will handle this order. And from the salesperson's perspective, actually, if there are many orders, the salesperson can handle many orders. So potentially, salesperson may handle many orders, but if there is no order in that area, the salesperson may handle 0 orders like this. So that's it. And the next, for each order, we have to create the invoice. So one invoice is generated by the salesperson and shipped to the customer. So we don't have a customer entity here, so we can let's create the invoice entity first. So for the invoice, we can have a invoice number as primary key. And in the next rule, it says that every invoice includes the total price, amount paid, and the balance due. So invoice will contain total price of order and the amount due, how much money the customer has to pay, and the balance amount paid, and the balance due. So basically, in the invoice, we keep this kind of information. The total price is the exact price of each order, and the amount paid is how much the customer paid so far, and balance due is how much they have to pay more if there is any amount left. So we can keep this information in the invoice. And for the business rule, each order, one invoice is generated by the salesperson. So basically, we can create this generate relationship. So each invoice will be generated by salesperson. And also, it says that and shipped to the customer. But if you look at the earlier ER diagram we created, basically each order belongs to one customer. So we know that invoice is also made for each order, and that can be shipped to the customer who is related to each order. So in this case, the invoice doesn't need to be connected directly to the customer, because if invoice is connected to the order, then we know who is the customer placed this order. So in this case, I'm going to create the generic relationship as a ternary relationship, which connects order, salesperson, and the invoice. And for the cardinality, we can think like this. So to define the cardinality here on the order side, we can think from the invoice and the salesperson perspective. So there is an invoice generated by a salesperson. How many order this invoice belongs to? It's only 1 and 1. If there's an invoice, it should be matched with one order. And also for the cardinality here, if there is an invoice for a certain order, how many salesperson can make it? It's also 1 and 1. Based on the business rule, the dedicated salesperson for that order will create this invoice. And the last part here, it's the same. There is a certain order handled by a certain salesperson. How many invoices can be made? It actually depends on the business rule, but here, based on our business rule, for each order, one invoice is generated. So we can put 1 and 1 in this case. But depending on the company's rule, and some company may create multiple invoice if they can charge each order to multiple people. But in this case, based on our business rule we inferred, we can create this ER diagram as you see in this screen. So that will be for the business event order handling. And the next one is employee management. So in the company, there are multiple employees. Also, the company wants to store employee information to manage them. If we look at the business rule in the company, an employee can be either salesperson or worker. So we can create that first. So employee. So we actually did something similar in our assignment. So it can be either worker or salesperson. So in our assignment 1, when we had this business event, I actually showed that we can create employee entity here, and there can be worker and salesperson. Then we can create two separate ER diagram like this. But if this ER diagram is 1 and 1 and 1 and 1, then actually we can combine them two to make a ternary relationship, because in terms of physical implementation, they are the same design. So in this case, I'm going to utilize the ternary relationship. So basically, if we utilize the ternary relationship, it will be like this. So employee can be either worker or salesperson. And if the person is a salesperson or worker, there should be employee. So they should be employee. And if there is an employee, he can be a salesperson or not. Also, he may be worker or not, like this. So basically, this design is exactly the same as making employee, worker, salesperson with two binary relationship like this. So they are the same thing. So we can store some attribute here. So we can have an employee ID to represent each employee, and we can have their employee name. For salesperson, because they can be either employee, they must be an employee, we can use the same employee ID as a primary key here. And also for the worker, because if they is a worker or salesperson, they must be an employee. And we have this supervisor relationship. So one employee can supervise many other employees, while each employee must be supervised by only one employee. So we can create supervise unary relationship like this. So one employee can supervise many other employees, while each employee must be supervised only one employee. So it's possible if I'm the lowest level employee, I may not supervise anyone, so it might be zero minimum cardinality. I make minimum cardinality here. Okay, and then so the next relationship, next rule is this: worker will work in manufacturing facility. So we can create the facility entity, which actually we created earlier. So facility ID is there, and then the worker works in facility like this. So a worker works in only one manufacturing facility, so 1 and 1 here. In each facility, there should be at least one worker, and there could be many other workers working in the same facility. So that's it for employee management business event. So the conceptual ER diagram for the employee management business event will be like this. Okay, now it's the last one, which is the purchasing raw materials. So this is quite simple. So the company needed to purchase raw material from their vendor to make a product, because they need the raw materials to create the product. So they want to also keep this information in their database system. So there is a vendor providing raw materials to the company. So raw materials. We want to keep that information. We already created this entity earlier. And also there is a vendor where this company is buying materials from. So they supply raw materials. For vendor, we can have a vendor ID as primary key, and we can have something like a vendor name and other information. Raw materials, earlier we made the raw materials ID as a primary key. So that's it. And for a certain material, the company can potentially purchase it from multiple vendors. So from the materials perspective, it can be purchased from multiple vendors, but there should be at least one vendor providing it. And a vendor provide, from the vendor's perspective, they may provide at least one, potentially many raw materials. So for this business event, so that's all. So for the simple business rules we inferred here, we can create this ER diagram like this. So basically what we did is this. So based on the company background and based on what company wants to store in their database system, we divide and we infer the 5 different business events, each for each functional area of the company. And for each business event, we are able to infer multiple rules like this. And once we infer a business rule like this, based on that, we can infer the ER diagram. So based on conceptual ER diagram, we infer the software. So we had 5 conceptual ER diagram. The next step will be basically combining them together like this. So between different diagrams, there are some common entity appearing multiple times. And based something like raw materials here, so this was one business event, and here was another like a business event like this. Then we can combine them together to create the integrated ER diagram. So this is the full picture of what they want to design as a database system. So once we have an integrated ER diagram, the next step is just simply translating this into the relational model like this, so that we can implement this in the database system. So once we have a relational model, then we can implement database system, basically following what we inferred here. So basically that's one exercise I prepared here. And I want to talk about some additional SQL query information so that you have like a full idea of what kind of different query exists in the database system. So basically, to recap, the structured query language is basically the language that we are going to utilize to communicate with the database system. So last time we talked about data manipulation language mostly. However, there are other SQL types too. The first one was data definition language, basically it's DDL. So last time I briefly talked about it. We use DDL to create, alter, or drop tables. Basically DDL can be used to design the database system. However, we didn't talk much about this because what we did last time is making the relational model first and using the relational model to create and populate database implementation automatically. However, if you use DDL, you can actually create or design your tables in your own way too. So I briefly talk about that later. And data manipulation language is basically what we talked mostly in this class because it's the most important thing, and this is the most frequently used SQL in the real world to retrieve information or to manipulate information for data analysis or other purpose. And there's also data control language. So if you work as a database administrator, so if you have that administrator position, then you may use data control language too. However, this control language will be only used by a few people in the company in the practice. So I didn't talk much about it, but I can briefly introduce what kind of language exists. So actually, SQL is very important to fully understand because in the practice, if you want to get a job as a data analysis or business analyst, many people will ask a question about SQL during the interview process because it's kind of things they expect you to know in the most of the cases. So it's always good to practice a lot to get yourself familiarized with the SQL. So I'm going to give you some brief additional information about other types of SQL we didn't cover last time. So one is data definition language, which is about create a table. So it's very simple actually. So if you want to create a table by typing SQL by yourself, you can simply utilize create table statement. And then you can specify the name of the table you want to create. And you can open parentheses, and you can later close parentheses with the semicolon. And inside here, in each line, you specify what kind of attribute you want to create in the table. So the first part is the attribute name, and then you specify the data type for that attribute, and you specify additional option. So in this case, for step ID, I put not null because step ID will be used as a primary key. So it shouldn't be empty. Every row must have a certain value on the step ID. For other attribute, I did the same thing. For other attribute, I put the attribute name, the data type, character, 45 number of characters. And after you specify all the attribute you want to create in a table, you can specify what will be the primary key in this table. So I say that primary key should be step ID, like this. So that's it. And to make a related table, you need one more information. Everything is the same, but in the last part, you have to add this foreign key information. So I specify this table, permit table, will be related to the professor table. So I say that there should be foreign key, step ID, this attribute will be used as a foreign key, and it will reference, basically it will be linked to professor table's step ID. So that's how I specify and create the relationship by using SQL statement. So that's the create table SQL statement, which you can also utilize in the MySQL and any other database software. And another data definition language is this. So if you are able to create a table, you can also modify or change or delete the table. So there are some statements for that. So at first there is an alter table statement which you can use to modify table structure. So you can use that, you can specify the table name, and later you can specify what to do. So if you use add, you are adding additional attribute. So last time what we did is that in the MySQL ER diagram editor, we added one additional attribute and we used the synchronization. Instead of doing that, you can also simply utilize SQL query too. So in this case, I use alter table, professor table, and add department attribute with this data type. So that's what I did. If you want to delete a certain attribute, you can use drop instead of add. So I can specify drop, which attribute I want to drop, and I can specify I specify the data type. Actually, I think it's a mistake. I think I don't need to specify data type. I mean, you can try. I think that's not necessary. And also, you want to keep the attribute. You only want to delete a relationship. Then you can simply drop the foreign key. You can do that. So if you in the permit table, currently step ID here is used to make this relationship with the professor table. But if you use drop and you specify foreign key step ID, the step ID attribute will be still in the permit table, but only the relationship will be removed. If you want to add foreign key, you can use this. So add, and you can specify foreign key and step ID, and basically same as what I talked earlier. And if you want to delete the entire table, you can simply use a drop table statement and specify the table name. So those are some additional SQL you can utilize for data definition language in this case. Okay, so another one is DCL, which is a data control language. So data control language, earlier as I mentioned, it will be only used by database administrator because there are a lot of like user management or privilege management information you can control in the database system. So this is very sensitive information, and when you use DCL, you have to be very careful because if you make mistake, it's very difficult to undo what you did in the database system. So actually, these kind of options like creating user or granting different privilege onto user or removing a user from the database system, you can actually do all of these days by graphical user interface. So if you use MySQL Workbench, last time on the left top corner, there is a schema tab. So you can see the list of database you have in your server. However, the next tab is administration tab. If you go there, actually you can manage this kind of setting simply by clicking and by clicking a button. However, if you want to design a SQL query which does the same job, then you can utilize this kind of query. So there's a create user query. If you want to make a new user on your database server, you can use create user and the username at localhost. Localhost is basically IP address of your database server. So I used the localhost here because I'm going to use database server installed on my local PC. So then you can use localhost. So so far when we practice the SQL in our class, we only use the root user. Root user has all the privilege, so you can do whatever you want. But if you make a different user with a different privilege or limited access to the database system, then you can create new user like this. And you can specify identified by, and you can specify the password of that user like this. And once you make a user just like this, the user can connect to your database server, but the user will not be able to do anything because you didn't give any privilege onto the user. So after you create the user, the next step what you have to do is giving appropriate privilege to the user. For that, you can use a grant statement, and you can specify type of permission. So type of permission will be something like this. You can give all privilege, then it will be same as the root user, or you can give only create drop, something like this. So you can specify what you want, and select insert update delete, or something like this basically, grant option. So if you give a grant option, that user can also give a privilege to another user, something like that. So usually, in the company, let's say that there is a database administrator and there are many like data scientists or data analysts. So database administrator may want to give only select privilege to the data scientist. That's also possible because the job for data scientist is reading data what company has, and they are going to analyze. But they are unlikely change the data company already has. In that case, you can only give a select permission to that user. So you can choose appropriate permission for different role the employee has in the company, basically. So in this case, we can use grant, and you can specify type of permission, and we can use on. And here, we can specify database name and the table name. So for each table, you can give a different permission for that user. And who you want to assign that privilege, you can specify that. So here are some simple statements you can utilize in the future if you work as a database administrator, or if you have a similar position. So revoke is basically taking back the privilege you gave to the user. So it has the same statement. And drop user is basically deleting that user information from your database server. So that's it. So basically that's type of the data control language people will use in the company if they are working as a database administrator.